Our next speaker is Conor Woods. Conor is a seasoned software developer with over 25 years of experience, yet he's passionate about learning and keeping up with tech trends. Conor excels in leveraging technology to boost productivity. He's here today with the title, The Dead Zone, Plotting Graves in Low Connectivity Environments. Over to you. Let's hear it for Conor.
Thank you very much, and welcome everybody to one of the last sessions of NIDC. So this is commonly known as the graveyard shift. So I don't know whether the organisers put me here on purpose, because we're going to be talking about graveyards. We're going to be talking about completely offline apps, talking about progressive web apps, going to be talking about sync engines. So we'll just get started. But before we start talking technology and all those lovely things, let's talk about the problem that we're trying to address and who we're trying to address it for. So I'd like to introduce you first to my mate Paul. So I've known Paul for many years, and he has worked for 25 years as the sexton of the local Presbyterian church in Ballycastle, which is where I am from. So what a sexton is they're basically the caretaker of all the grounds of the church. So you would see Paul mowing the grass, he would be repairing the headstones, organising ceremonies, and basically, if you went into the graveyard to ask about a relative, then generally Paul is the person that you would see whenever you went in. So he's been there for 25 years, and he knows everything about that graveyard. And the graveyard that we're talking about isn't that large, so we're talking around 600 plots therein, with about 1,000 interments, which is dead bodies, in the cemetery. And the way Paul manages that, the way Paul keeps a track of who's in what grave and who's where and who's paid and who hasn't, is with Paul's big blue book. And this is what it looks like. And Paul's been doing this for 25 years, and he's built up this book, and this is the source of truth for the graveyard. And it's all written in a code that only really Paul understands. So Paul's predicament is that at some point, he's been doing this for 25 years, but he's going to need to retire sometime. And he needs to remember who's in what grave. So he does get questions from people all the time coming into the graveyard, asking about relatives. Paul's a clever guy, but you've got 600 graves with over 1,000 people he needs to remember. There must be a handier way to do that. He needs it to be searchable, both for himself and for people coming in, for loved ones coming in. And basically, he needs to digitise Paul's big blue book into something more manageable, and it's going to last into the future. So what I didn't mention at the start of the talk was I work for a company called Plotbox. So we are a local company based in Ballymena, but we operate globally. And what we do is we provide software for cemeteries and graveyards. So what we would normally do if a cemetery comes to us and comes to us with a problem, like Paul's predicament, is what we would normally do as a company is we would send out a scoping team to that particular graveyard and cemetery. We would then send up a drone into the air to get detailed imagery of the entire graveyard or cemetery. And then we'd have a team of mappers that would try and marry up that imagery with their current records and basically try and digitize everything. And at the very end of it, give them a platform that they can then use. So this is a picture of us going out with a drone, first of all. A pretty cool job. We actually have drone pilots as a job title in our organisation, and it is a pretty cool job to have. We would then try and take their paper records, like if they have paper maps, which are useful, but we need those in a digital format. And we try and digitize things like Paul's big blue book and put those into a database and marry those records up with the high resolution images that we've taken from the drone. And at the end of the day, give them a full management solution so they're able to manage their sales, They're able to manage their marketing, scheduling burials, services, cremations, and organising work crews to go out and maintain and repair the entire cemetery. And for some of the bigger companies or the bigger graveyards that we would work with, give them things like full flyby imagery so that the staff can go in and see, can go in and manage the entire cemetery, and also for loved ones as well who want to go in and want to look at memorials to their loved ones from the comfort of their home. So that's what we do at Plotbox normally. But we're talking about Paul here. So Paul is a part-time in the Ballycastle Presbyterian Church. He also only has to look after 600 plots as well, whereas the companies that we're talking about at Plotbox are places like Roselawn in Belfast. We would manage them, and also large enterprises like Rookwood in Australia, who span over 500 acres and have over 1 million internments there. So Paul has a different set of challenges. And the unique challenges that Paul has, he doesn't have the budget for what Plotbox do. He needs it to be pretty cost effective if we're looking to help him. He needs whatever we do for 1 or 2 people to undertake the challenge. So he's going to go out and he's going to have to try and digitise all of the existing headstones out there. And he can't do all that himself, so he needs somebody to help him. He needs it to be able to be used in the field, so in bad lighting and bad weather, he's going to need something that can be usable there. He's got an old mobile phone, he's got an Android Samsung S12, but he also needs it to work with iOS as well. Because he doesn't know, the person that's helping him doesn't know what type of phone they have, and he needs it to be easy to use, and overall, he needs it to work in an offline environment. And this is primarily what this talk is about, is trying to find that solution for Paul to solve Paul's predicament, but to do it in a fully offline manner so that he can go out, rain, hail or shine, internet or no internet, and whatever he's using is going to work just as well with or without that internet connection. So basically, what we came up with for Paul was an onboarding procedure, first of all, so he would define whereabouts his graveyard was first. And why that's important, I'll explain in just a moment. Why that's important for taking him offline, I'll explain in one moment. And essentially give him an app where he is able to go out with his mobile phone, to go to any of the headstones, to be able to stand at the bottom of the grave and to take an image of that headstone. Then for the app to then transcribe that image, and for him to then place that plot on a map where exactly it is located. So he can choose from a single plot, a double plot, or an urn, and he can move the direction on the map so that he can place that plot in exactly the right place, and then rinse and repeat for each of the headstones that he finds, that he has in his graveyard. So as you can see here, what's happening is it's transcribing the data from off the headstone and then dividing it into the different people that are buried in that plot. So everything's nice and digitized for him and searchable for him, and trying to do all this in an offline manner. So that was the challenge. So a pretty simple idea, but really challenging whenever you want to take it offline. And there were 3 big offline challenges in particular that we had to address for this. So the three big issues that we had with offline were, first of all, the maps. That mapping that you saw, how do we take that fully offline so that if there's no network whatsoever, it'll still work? The other issue was with plot images as well. He's taken high resolution images of each headstone, and we just can't store all those and then distribute them to everybody using the app, so we'll have to solve that problem. And the biggest problem of all was the data, trying to make that data fully offline, both for Paul using the data offline and for anybody else using the app as well. So what's the problem with maps? Well, the problem with maps is if you've ever gone on to Google Maps or anything else and used and opened up your network panel, you'll see as you pan and zoom around the map, the network activity goes crazy. So it tries to download each of those individual images for the particular zoom level that you're at and the particular position you are on the map. So lots of network activity going on there. So not really conducive to being offline where there is no network at all. So what solutions do we have? Well, we've got one thing working in our favour. First of all, we asked Paul to constrain the map. So only let us know what part of the map that he's concerned about. So only his graveyard, so only about a 500 metre by 500 metre radius. And also we get to constrain the zoom level as well. So we fully restrict how much data we actually have to work with. And then what we could do at that point is we could download each of those individual images that we need for all those zoom levels and for each of those positions on the map. But even that is a lot of network activity. That's a lot of work up front. If you try and hit a server for that many images at the one time, it's not going to like it. So are there any other options? Could we do it with a single file, for instance? Well, the answer is yes, you can. There's a library out there called PMTALs, which will allow you to make up one individual file with all that information contained within it. And not only that, usually with a map, what you need is a map server. So you need another piece of technology to serve all those images down to your users. With PMTALs, all you need is an image. So if you have Amazon S3 or storage anywhere, it's just a simple file that you can store there, and the library will just ask for the particular bytes of that file for the zoom level and the position that you're at the moment. So even better than that, than storing it on S3, we can actually generate that file and bring it down locally and store it locally, so about 1 megabyte or 2 megabytes in size. So now we have our map fully offline with that single file. So that's maps. That's one of our three big issues. We're doing it with a single file download, and we're constraining Paul to a particular area. What about the plot images? What's wrong with the plot images? So as I showed you in the video at the start, Paul's going up to every grave headstone, and he's taking a high-res image of that headstone. Now, even with a graveyard of 600 plots, that's still going to mount up on a phone. So what can we do there about all those images? So there's two things we can do. We can leverage, because we're talking here about a web app, so not a native app, but a web app, we can utilize the cache API to be able to cache those high-res images locally, and to let the web API sort out when we fill up in size to purge that cache again. But that doesn't help people who haven't already downloaded that particular image. So what we can do on top of the cache API is to just talk about thumbnails. So feasibly, with only 600 plots, with only 600 images, with only 600 thumbnails, that's feasible to download all those images up front for each user of the app, and then just to use thumbnails locally from that point on in the app. If you've got a network connection, great, go up to the full res image. But if we're fully offline, we're okay, just use thumbnail images. It's a slight degradation, but it's acceptable. So that's plot images as well for one of the big problems. We're using the cache API, and we're also using thumbnails as well on each device. So the biggest problem of them all is data, how to make data fully offline. One of the big problems with data is the multi-user problem. So if I'm out helping Paul in the graveyard and we're both offline, and he's cataloguing some graves, and I'm cataloguing some other graves, and Paul goes off on lunch, and I start doing the graves that he was doing earlier in the day, and then at some point we get network connectivity, then that data is going to have to merge together, and that's where you have conflict resolution in the data from my offline data and Paul's offline data. So that's one big problem with taking the data fully offline. The other one is where to save that data as well. So with a native app, usually what you have, you can have a local database locally, but until a few years ago for web apps, that wasn't really an option for us. We had cookies, we had the cache, but it wasn't really great. But now with the enhancements in the browser, we can now use local storage. We can now have background processes. We can even run WASM as well, so we can run SQLite and store that data locally. So we now have options. Okay, so the problem, so this is an architecture of what we're currently doing at the moment. So we have our front end, we have our back end, and we're saving to the data store. And the problem comes in is the way we're normally architecting our apps at the moment is that when that network goes away, then the app is just a brick in your hand. You're scuppered at that point, which isn't great for a user experience because your local network does go away, whether that's bad Wi-Fi or whether no mobile data at all. But also on the other side, on the cloud side, those cloud services do go away at times, whether it's a DNS problem at AWS or whether it's a DynamoDB problem at AWS, and other cloud providers are available and they do go wrong. But yeah, they're just the more recent instances of what can happen. So it's not a great user experience in that regard. But it's also not a great user experience because what we're doing whenever we're relying on that network is that, say a user goes to do a save operation, that request then has to get encrypted. It has to get sent over the wire, has to get decrypted at the other end, has to get processed by our backend, then has to connect or try and connect to the database, which may or may not be on the same machine. It might be on the other side of the world. Needs to go through all that process again and backwards decryption, the whole thing. And all the while, the user is standing in a rainy graveyard on a pretty grim day, just watching a spinner go along while all this happens in the background. So not a great user experience from that perspective as well. So what can we do? How can we take that data offline then? Well, one feasible option is to never let the data leave the device at all, ever. So no cloud servers, no external servers at all. And there are cases where that's a pretty feasible way to work. If Paul was the only person ever using that app, then Paul could happily use that app away and maybe give him an export functionality so he could download his data to CSV, but it's perfectly feasible. But Paul wants multi-user, so he wants two people using the app as well, so we need to be able to synchronize between two devices. So how can we do that? Well, again, this is another architecture that you could use, again, without cloud services at all. It just has two devices talking to each other directly with no external network. So by using Bluetooth or by using the same Wi-Fi network, you can enable devices and apps to talk to each other. You can, in theory, do this. I tried, I failed. It's really difficult to do, so I gave up and went with option 3. So option 3 then is the best of both worlds. So we do have cloud services, we do have our database on a faraway server, we do have a backend, but what we're primarily doing is working off local data. We're reading and writing from local data. The app is just happily away, reading and writing from local memory. And in the background, when we get a network connection, again, at that point is trying to synchronize them with the cloud server. So putting a sync engine in between our app and the cloud services. So it leads for a really good user experience because it's a pretty fast application. You don't need any spinners at all. It's just reading and writing from local memory. And then the network connectivity is then just passed off to a sync server. And this is the kind of architecture in practice that we started using. So we had Supabase in the background just for the database. The client app was just a normal view application, but in the middle was where the magic happened, the sync server. So I ended up using PowerSync in the end. Other options are available. If you can, check out zero.dev. It's another persuasive option, but the one I went with, just because it was easiest to use, was PowerSync. So we have our three big offline issues sorted. We've got the maps done with our single file, with our PM tiles file. We've got our plot images. We're utilising thumbnail images and we're downloading those locally to go fully offline. And we've got our data. We've put our sync engine as well in between that. So job done, super. We're fully offline. But does it work in practice? Well, the thing I love about NIDC is that whenever you come to NIDC, you've got developers talking to developers, you've got tech people talking to tech people, just trying to impart some wisdom about what went right or what went wrong. It's not some sanitized version of what happened or marketing department approved experiences. So warts and all, this is what worked in practice and this is what did not. So first of all, the storage. Were we able to utilise the storage that is now available on browsers to create a web app, to create a progressive web app that would stay within the limits of the browser? And the answer was, yeah, pretty much. It worked out about 30 megabytes in total for all our thumbnails, our map file, our libraries, and our small cache. So it did work. And progressive web apps can handle this type of environment. What about costs? Like I said, Paul didn't have any budget at all to speak of, so we're trying to keep it as low as possible. So the hosting, we were using free tiers. The mapping is just a single file. We don't need a map server. We don't need Esri. We don't need ArcGIS, any of that, just a single file. That was free. PowerSync as well. It has a free tier which we're able to utilize. And all these free tiers, we will never get to the limits that Paul will ever need for his operation. And then Supabase as well, free tier. Again, the limits are very, very generous on those. The one thing that did cost money, and I'll get onto this in a second, is the AI. So it cost about 0.003 pence per grave, which works out around about £2 or so for the whole entire graveyard, which wasn't too bad. But I'll explain why AI didn't work. So what about the user experience? Well, it's because we're just reading and writing from local memory. It's fast. It's very fast. You're not having to put up spinners whenever you're doing network connections, and it's a really nice way to experience apps. It's resilient as well to offline to our network going down, and we're also not using app stores as well. So Paul didn't have to go to the app store to download it because we're using progressive web apps. He's just going to a website and the website's asking him, do you want to install this as a normal app? So again, no money, no setup. Again, a nice user experience. Where the user experience wasn't so great was with GPS. So the accuracy of Paul being able to place those plots accurately on the map while he's out in the field in bad weather while it's pissing down with rain is a challenge, and having the accuracy of the GPS and to know exactly what direction Paul is facing so that he can place that directly on the map was a challenge, and trying to give him a UI that would help him do that was a real challenge that still trying to get around. What about the developer experience? Well, with local first development, it's a really nice user developer experience because you don't have to set up Docker instances, you don't have to set up a local database, or you don't have to rely on cloud services. All you've got is just the code base, and you run it, and it just works. And you can keep on working. You can work on the plane, you can work anywhere because everything's completely offline as well. So a really nice developer experience. Another thing I couldn't get done was local AI. So with the browser, you can run WASM now in the browser. So you can port things like SQLite, and you can run AI models within the browser, which is really cool. And I tried it, and it was difficult, and I failed miserably because it turns out trying to transcribe the text that is on a headstone is a really, really difficult thing to do, and I couldn't do it with my AI model, so I did what everybody's doing nowadays and just picked the de facto large language model off the shelf and used it as a cloud service to do that for me. So it's not offline. I'd love to get that offline, but it's not. And decentralized authentication as well. So the way the security works is we ask Superbase to do the authentication. So you need to get a token from Superbase, first of all, which requires a network. You can do, in theory, decentralized authentication. It's really complicated. It hurt my brain. I gave up at that. It can be done in theory, but it wasn't for me, so that isn't offline as well. You need to connect, first of all, get a token with Superbase, and from that point you can use those sync services with Superbase and your local storage once you get connectivity again. Finally, some of the takeaways of what I learned was that local first, so creating an app that can work as well with a network connection than without a network connection. Sounds really simple, but it's really difficult to achieve development-wise. But it's worth the pain, especially for the user experience that you give users. You're giving them the resilience of enabling them to be offline and work in all different types of environments. But you're also it's also the speed as well. You really notice when you're using with a local first app or with a fully offline app how much quicker it is. There's no spinners at all that you're waiting on. You're not waiting on those network handshakes. You can really notice the difference when you're using a local first app. It's fast. But the one big takeaway, so if you don't take anything else away from this talk, try and take this away, that developers, whether you are a developer or you're responsible for developers, is trying to get them out in the field more, not always literally a field like a graveyard, but try and get them closer to the users more and feel their pain. Because some of the features that I was developing, I was coding away happily at my desk, and they were kick-ass. They were brilliant features. And then I even just went out into the back garden and tried them and just went, nobody is going to use this. Nobody could use this. If it's raining, you just can't. You just can't. You need to get out in the environment that users are to create better software. So that's the one big takeaway that I would give you. So thank you very much for listening. The end talks are coming up, but thank you again for your time.
Thank you, Conor, for the interesting talk. Do we have any questions for Conor? Yeah, so many.
Thanks, Conor. That was great. I have some sympathy for Paul because my mum's a local church warden up in Eglinton. I had a couple of questions. I won't ask them all because I'm sensitive to time. The geolocation of Paul, you were saying you had some difficulty with whenever he's offline, to get the plots placed right. I was curious how you did that. Like, are you using like gyro or anything to like sort of Does he start in the same place every time, and then it tries to figure out where he is based on the gyro in his phone, or?
Yeah, exactly. So yeah, being offline for GPS wasn't a problem at all, because it turns out GPS works even better when you're out in the middle of a field, and yet does use the accelerometers on the phone to know what way he was pointing. But it was just all that kind of maths involved with that was just really difficult to do. But in the end, it worked out pretty well. He can just move from grave to grave. He can point and get that accuracy on where he needs to put that plot, and he can move on to the next one, and it does see that he has shifted across so that he can go on to the next plot. So still refinement to be done there, but yeah, happy with the result.
Great, thanks. I'll maybe catch you after for the other question.
Perfect.
Cool stuff, Conor. You touched on how hard these things are to build. How did you find dealing with the browser environment? You talked about Paul using an old Galaxy S12, and I know how messy support is, particularly for the really cool PWA and IndexedDB stuff.
Yeah.
A lot of time we go native because the web is just a mess on
Yeah.
smartphones. How did you find dealing with that in this project?
It was great until it wasn't. Yeah, no, it all worked really well. It worked particularly well whenever it was on my laptop. But then, yeah, going out into the garden and using it on a phone was the big difference. I had a really bad problem with WASM as well. So I was trying to communicate with the different processes with the browser, and it was really slow at doing that. Mainly because it was my fault, because I was trying to put too much data in the local database. I was trying to put the full res images in there, and then it was trying to deserialize them between the two processes, so that really slowed everything down. But once I focused and dug deep, which another another pun, then I was able to get it nice and fast. And it does work.
We are really close to time. We can take one question.
Thanks very much. That was great. I'm just curious if there was anything you came across during this project that you thought could be brought back into Plotbox's main product?
Sorry, I should have mentioned that as well at the start. Yeah, I was doing this as a hobby project just for Paul. This isn't publicly available or sanctioned, but yeah, definitely that process of Paul going out and the transcribing as well, and being able to accurately put the plot exactly where it needs to be in the map. We could definitely bring that in the Plotbox, because at the moment it is very much it's a large scale effort, and it is being done back in the office by our team of mappers. But we do deal with smaller cemeteries that we could go in with such an approach where they can do their own mapping without having to send in the drone, without having to send in the team of mappers. So absolutely, yeah, on Monday I'm going to try and trying to bring some of these things back into work.
Thank you, Conor. We are going to have our end note in the Lagan room.
Yeah.
So, thank you.
Yeah, thank you.